Hi, I'm Bailey.
I am John.
Hi, I'm Dave. Alright, so here's our project goal. We want to make a fully functioning Game Boy Color, and we really want to play Pokemon on it. So this is what, at the end of the semester, you're going to see us battling it out, because we're going to make a link cable so that we can, be battling. Alright, we also want to get sound working. And we have this built in, and this is a stretch. But we would like to see a custom bootloader where we could load multiple games rather than having one cartridge at a time. So that would be cool, and then we would have a screen that would pop up like this, and you could just simply select the game by pressing the buttons.
So you must be wondering what project we're going to be using for this Game Boy Color project. We are going to use the Vertex 5. Yay! So let's see. So we chose to use the Vertex 5 because the number one reason is that it has the DVI port that is tested and dependable. We heard about the problems on the Vertex 7 with the HDMI, and we do not want to deal with that, so we decided to use the Vertex 5. Also, other reasons are it's well tested in the years, so debugging board problems will be relatively easy, hopefully. And then also we plan to stick with the Xilinx tools, so yeah.
Okay. Alright, so I'm going to talk about the research we've done so far about the project. So here we have a general idea. Here's a block diagram, a rough block diagram we drew of the various components. We basically divided the project into some main components. So here they are in approximate order of how important we think they are to get a functioning project that can do things. So obviously we need the CPU, the memory system, and DMA. So the memory system, would be things like the general memory map, such as which parts of memory connect to the controller interface, the working memory, the I/O map registers, and then we have the PPU for controlling the screen output. And obviously we have the DVI interface for actually outputting things to the screen. And finally we have sound. So if we were to add our other project goals, which were mentioned earlier, we would probably have like the link cable interface, and then our custom bootloader, which would be lower priorities. Let's see. So we researched about existing. So the Game Boy Color uses a Z80 CPU. We researched some existing CPUs on OpenCores and some other sites. So we think we found the core that the previous team to attempt the Game Boy Color used, but they said it gave them a lot of trouble. So we'll look at the code to see if. So the advantage of that core is it comes with a Game Boy mode, which would. So the Game Boy uses an altered Z80 instruction set. So we can't pick up any Z80 core, and that particular core had a Game Boy mode. So we were thinking we would give it a try to see if it gave us too much trouble. We would abandon it right away. And then our second choice option would be to find a solid Z80 implementation and modify the core to fit the Game Boy ISA differences. We also investigated various options of how we would implement the memory map. And yeah, I guess that's about it. Is there anything else?
Alright, so to get our project done, we have developed a very elaborate schedule, which we call our overly optimistic schedule because, well, it's a lot to do and we're trying to do it in a short amount of time. So, but we figured, we want to be optimistic because we want to push those deadlines as soon as possible. So for example, we're trying to get our entire system integration done in 4 weeks. So that way we have the rest of the time to start debugging, and we can add some more peripheral features such as the link cable, the sound system, and the custom bootloader. So for me in particular, the first 4 weeks, I will be working on the memory system. We chose me for this task because I have a lot of FPGA experience and working with the different FPGA tools. And that's going to go in finding a lot of different Xilinx IPs that we're going to need to be using. And then also, at the end of that, I'm going to be implementing the DMA. So by the end of that, I should have a fully functional memory system, and it's going to be tested thoroughly. And then after that, we're going to leave some room for debugging after we do our system integration. And then I'm going to switch gears, and I'm going to go and I'm going to start doing the sound for 5 weeks. We gave this about 5 weeks because this is a weaker area for all of us. So we figured we should be giving a decent amount of time to do that. And then we left some buffer at the end to do some debugging in the last 2 weeks. So that's my contribution.
So what I'll be working on the first 4 weeks will be on the CPU. Hopefully we'll find a good implementation and I don't have to write out the whole thing because I doubt I can do that in 3 weeks. But I will probably be modifying some code and make sure that it's robust. I've been assigned to do that because I have experience testing for the past internships, and hopefully this wouldn't be too bad. And then I'll be working on the controller input right after that, same debugging. And then I'll be working on the link cable and just help out with other, I guess, here, and then just the same debugging.
Hey, so I'll be working on the PPU and display interfaces. I wanted to do these mostly because I was interested in them and have some experience with computer graphics. So we allocated 4 weeks for this, and we expect it to require a lot of debugging. Obviously, of course, in between these other tasks, we would probably switch in for debugging and stuff as needed. Later on then, I'll work on the compact flash interface and the bootloader to allow us to store multiple game ROMs to load them. So, and of course, more debugging. So yeah.
Debugging!
Debugging! Alright, so we want to conclude with a note on how we are going to tackle accountability of our team members. And I'm a big stickler for this, so my team has named me the Quality Assurance Engineer. So to do that, we're going to have weekly progress meetings. So in those periods where we're all four kind of doing different things, we're going to be meeting up around maybe lunch or happy hour. Woohoo! Woo! And we're just going to be, that's just solely going to be catching other teammates up on our work and our progress. And the goal of this is down the line to help with debugging so we know what the other person's chunk of work is actually doing. Furthermore, each team member is expected to break down their chunk of work into smaller pieces, saying like, oh, I'm going to have the documentation done by this time. I'm going to have the processor ready by this time, so that we can hold them accountable for that schedule that they made. On another note, we also developed coding standards quite early on. In the first week we were here, and we all agreed that was very important. And we also all agreed that design documentation was really important, because that will also help us get an understanding of what everyone else is doing in the project. So that's how we're going to get this done. Bye!